Good evening, students. Am I audible? The screen is visible. I have uploaded the PPT. Have you gone through the PPT? Aryan, have you downloaded the PPT and gone through the PPT? Shall we start the class?
Yes, ma'am.
Any doubt in previous class portions? So in the previous classes, we discussed introduction to algorithm design complexity, asymptotic notations, data structures, and the introduction to data structure and classification of data structure. I think abstract data type is pending. So in complexity, we discussed in terms of time complexity and space complexity. So from this diagram, you can easily understand. Already we discussed, but if you from this diagram, say your algorithm's time complexity is order of one means irrespective of the number of inputs, and the time CPU time will be order of one only. So this is 0, 1, 2, 3. So it is a straight line order of one. If it is log n, the complexity is log n means like this. This particular curve, order of n, for n inputs, the time complexity increases exponentially. It is order of n. So this is order of n log n, order of x square, x cube, 2 to the power of x, and order of n factorial. So for one input itself, for n inputs, it's exponentially increases. As we discussed, time complexity is how many operations are necessary to perform the computation as a function for the input size of n. So how much time we need to complete the task for the given input of size n. Space complexity means it is represented as S of n. How much memory is so time complexity is represented as T of n, and we are using big O notation, big omega notation, and big theta notation. And space complexity is represented as S of n, storage, and it is how much memory is necessary to perform the computation as a function of for the input size n. Say for sorting, if you are giving 100 numbers, how much memory space, 100 integers, how much memory space you need to store the numbers and to complete the task. And how we are computing means the rate of growth means when the input size increases, we are increased in how fast the function T of n and S of n grows as a function of the input size n. So while representing we are taking this growth function. So this is the growth function. It is a space complexity, time complexity, and the growth function. Time and space complexity. Time complexity is based on the number of steps, and space complexity, number of memory cells used by the algorithm besides the inputs. Examples of space usage is it may be finding the minimum search or selection sort, insertion sort. No extra space is required. So in that case, the space will be order of one only. If it is merge sort, extra space we need because we are merging and we are sorting, so we need order of n. We need extra space of in merge sort, order of n, extra space also. So anyhow, while discussing the logic and algorithm, the remaining topics about merge sort, cell sort, all those things, you can easily understand. So the notation and the name and how it is, say order of one means it is a constant one, irrespective of the increase of number of inputs, it takes order of one. It is almost constant. Speed does not depend on the size of the data set, always takes the same time. So from this diagram, you can easily understand order of one, a straight line constant, irrespective of the number of inputs, 10 inputs, 20 inputs, 100 inputs, 1000 inputs also. Order of one, if the complexity is order of one, it is a straight line, it is almost constant. But if you take log n, order of n, n log n, it differs. So if the time and space complexity is order of n, log n means it is logarithmically progressing. 10x the data means 2x more time. When the input size increases 10 times, the complexity, space complexity and time complexity increases 2x time. Amount of work is divided by 2 after every loop or iteration, especially in case of binary search. So if it is order of n means it is a linear. For n inputs, we need big O of n. So 10x the data means 10x more the time. Time to complete the work grows in 1 to 1 relation to the input size. And if the function is n log n means it is logarithmic one. This is a nested loop where the inner loop runs in log n time. Examples include quicksort, merge sort, heap sort. So it is logarithmically progressing n log n. Quicksort, merge sort, and heap sort. Order of n square means it is quadratic. Time to complete the work grows in when the input size increases. You can recognize this whether you have a loop that goes over all the elements. And if it is exponential, means order of 2 to the power of n for n inputs. Time to complete the work grows in 2 to the power of input size. This is a lot slower than, so it is taking large time, n to the power of 2. So do not confuse. One example is recursive Fibonacci algorithm. So if you are using recursive method, it differs. If you are using non-recursive, it takes more time. Say for example, if you compare, we were discussing the asymptotic notation, big O notation, big omega notation, and big theta notation. Big omega notation is best case or average case or worst case. Can anybody tell?
Big O is for worst case.
Yeah, because we are taking the maximum time to complete the task. Say for example, if you take, we have a number of sorting methods, no? Quick sort, merge sort, heap sort, we will be studying in the remaining chapters. And if you take quick sort, in best case, it takes n log n, average case also n log n. In worst case, it takes exponential, n to the power of 2. Merge sort also n log n. Here, merge sort is almost somewhat okay. So n log n, and the corresponding space, this is a time complexity, this is space complexity. Heap sort, if you take n log n in all, and heap sort, it takes order of 1. You take selection sort, because we have to select and place, it is exponential in the best case, average case, as well as worst case. Space complexity is order of 1, depending upon the number of elements. Bubble sort, order of n, or n to the power of n, average case. Worst case, n to the power of n. Insertion sort, order of n to the power of n. take cell sort, bucket sort, and Radix sort. So they are using some additional parameters. So it takes order of n or order of nk. And space complexity also depends on the number of inputs. So yesterday itself we discussed what is complexity. In general, we can categorize the types of complexity as space complexity and time complexity. Space complexity is the amount of space required by an algorithm to execute the program. And time complexity means the amount of time required by an algorithm to execute. Time required and space required. Asymptotic notation also yesterday itself we discussed. So here, if you take the best case, average case, and worst case, in terms of big O notation, if it is order of 1 means it is almost constant. Log n means it is progressing, and the order of n means it is almost diagonal. Order of n square means exponential. Here the same given. The various sorting methods. What is the time complexity in best case, average case, worst case? And the worst case, space complexity. For n numbers, how much memory space we need. So the data types and the data structures introduction classification we discussed in the yesterday's class. We discussed primitive and non-primitive, linear and non-linear, difference between linear and non-linear. Linear means in a linear data structure, data elements are arranged in a linear order. And if it is non-linear data structure, data elements are not in sequence. Each and every elements are attached to its previous and next adjacent. So each one is having its own index value. So we can easily identify which is the predecessor and successor. In linear data structure, single level is involved. But if you take non-linear, every data elements are attached in a hierarchical manner, where in non-linear data structure, multiple levels are involved. So already we saw the examples for linear data structure and non-linear data structure. Linear data structure means array. So linear sequence of continuous memory location from 0 index to 5 numbers. And if it is stack, it is vertically representation. We'll push the elements and we will pop the last element. Last in, first out. Add and remove, or push and pop. If it is queue, it is first in, first out. The first person who entered and standing in the queue, it is one way to add, one way to remove. Add and remove. We will add in the rear and we will remove the elements from the front. Front is beginning, rear means end. Through rear, we will add into the queue. Through the front, we will remove the elements. In case of stack, it is a stack. Like CD, we will be putting the CDs in a CD container. Or if you take the hotels and all, they will take the bill and they will put it in a stack, or in a, they will punch everything in a stack. To take linked list also, the first element, second element, and element as well as its address. So it is also linear. Array, stack, queue, and linked list will come under linear data structure. But if you take non-linear data structure, graph. So here we have vertex, and each and every vertex is connected through the edges. So here we have 6 vertexes, and each one is connected with through the edges. We have root node, child node, or it may be cycle. Here we are using colors, and in the it may be greedy method. The adjacent node should not take the same color. And if you take the tree structure also, we have the root node, and we have 2 child nodes, and we have leaf nodes. So it is non-linear data structure. And already we discussed this lab program, linear search using recursive and non-recursive methods. So our next topic is, so we completed all those topics so far. We are entering into abstract data type. So any doubt so far? So what will be ADT? I think you might have studied in OOPS using C++ also. What is abstract data type? What do you mean by abstract? Abstraction. We can say classes are the abstract entities. Can anyone explain what is abstraction and abstract data types we have? Abstract data type is a collection of data and a set of operations that can be performed on the data. We know very well class is an abstract data type. In class, we are taking the attributes or variables along with the functions. So variables as well as functions as a single entity. Data and member functions are encapsulated with each other, and only the member functions can make use of the data members, and data members will be used only by the member functions. So that we are in that way we are enforcing data hiding also. So the classes are best example for abstract data type. In classes we have variables as well as functions. Same way in the abstract data type also, it is collection of data as well as set of operations. Data is attributes, operations are functions, or data members and member functions. Both are encapsulated with each other. And data members will be based on its visibility or access specifier or scope of the variable, may be private or public protected. If the accessibility is hidden, only the member functions can make use of all the data members. It enables us to think abstractly about the data. We can separate concepts from the implementation. So the implementation part is hidden from the end user. Only the abstract things are shown to the end user. Typically, we choose a data structure and algorithm that provides an implementation of the abstract data type. So in data structures and algorithms also, the implementation is hidden from the end user. We are giving the input and we are retrieving the output. Say the abstract data type. An abstract data type is a data type that is organized in such a way that the specification of the objects and the operations on the objects is separated from the representation of the objects and the implementation of the operations. Say here specification means the declaration path. Operations means the function declaration and definition, member functions. Representation means how we are representing the class declaration and definition. Implementation means the functional representation. The best example is if you take the ATM machine, what is the abbreviation for ATM? We are using ATMs now. What is ATM? What is the abbreviation of ATM? Can anybody say? What is the abbreviation for ATM? M is machine. T means what is A?
Ma'am, it's automated teller machine.
Repeat once again. Automated
Teller machine.
So in a ATM, if you take ATM, all-time teller machine or automated teller machine, the end users are accessing the ATM machines to debit the money, to know the balance mini statement, or to change the mobile number, or for cashless transaction and deposit also. So in that case, whatever happens in the middle layer and in the back end, in front end, we are accessing the ATM machine through the screen, user interface, monitor. Just we are inserting the debit card, and we are entering the user password alone, and we are choosing various transactions, credit, debit, balance, all those things. So in that case, if you are choosing the debit process, say I have balance of around 10,000. I am debiting around 1,000. The transaction after dispensing the amount, the balance will be updated from 10,000 to 9,000. So the backend process, how it is performing the debit process and how it is updating the balance and how the database is updated in the backend and how the centralized system through internet and Wi-Fi, it is updating my debit and credit process, each and every process in the main server as well as in other servers. So if I debit 1,000 here, after half an hour, I'm debiting another 1,000 outside the country. So the amount is concurrently, it is updated in all the machines. As soon as I make one debit process here, the next moment my balance is reflecting in uh, through the uh, through the internet and connection through the concurrency. The balance is updated. Wherever you check my balance, it will be the same. The same way if you are watching the cricket match, so the scores, we are getting the score details as well as in the share market, the ups and downs of the shares, the current petrol rate or the current today's gold rate. All those things are every day it's increasing and decreasing dollar price. So as soon as the price is increasing or decreasing, it's reflecting in throughout the world. The same way, uh, so how it is happening means through the concurrency because we are using centralized servers and centralized databases. But the internal transaction processing layer and the backend database layer and the security layer, transport layer, all those transactions are totally hidden from the end user. Only the end user or the customer seeing everything and they are interacting with the system only through the front end monitor. So it means the implementation, representation, and the various operations performed in abstract data types are totally hidden from the end user. Only the necessary details are shown to the end user. So the abstraction also maintained, implementation details also hidden, and the representation of various data and functions are the representation and data are separated and it's performing the operations. So the ADT operations, only the operation name and its parameters are visible to the user. Whether I am doing credit process or debit process and what is my balance, that is shown to the user, visible to the user through the interface, through the monitor. So the ADT operations are totally hidden from the end user. It's all happening in the back. In that way, we are maintaining the abstraction. So in abstraction means, say for example, if you are creating a student class, the student is having thousands of properties, thousands of characteristics. But while creating a student class, we are taking maximum 5 or 6 variables or attributes. Say the student registration number and department from student registration number itself, we can understand whether the student is first year, second year, which department, everything we can predict. And the name is required and what are all the subjects registered and how many marks is scored. So your student class may contain registration number, name, subject names and marks. And the same student is having n number of variables, but we are not taking all those parameters. So we are taking only the abstract or necessary details, that is called abstraction. The implementation and independent, so the implementation and each and every operation is independent, they are not dependent on each other, so that the cohesion and coupling will be reduced, so the efficiency will be increasing. I think you might have studied in operating system deadlock, cyclic check, how we are avoiding the deadlock, what do you mean by deadlock, the process of scheduling, organizing, what is deadlock. I think you studied operating system last semester, na? What is deadlock, how we can avoid a deadlock, what are all the methods available? Anyone? The same way, by taking the abstract data types and hiding the implementation details, representation details, and all the operations from the end user and showing only the necessary details to the end user, the burden of the end user is reduced. and we are making user-friendly systems. So every time if you ask the end user to enter his name, account number, mobile number, and his password, they may forget something they cannot able to access. But every time we are asking only 4-digit password to perform all the tasks, so that we are making the user interface so friendly, so easy, and they need not remember much data. Even the 4-digit pin number also we are forgetting so many times. So in that way, the abstraction helps us to create more user friendly, more user interactive, and usability of the system is increased. And abstraction is generalization of operations with unspecified implementation. So we will generalize all the operations because we are creating classes. The same from the same class only we are creating the objects. Each and every object represents each and every customer. But the template for all customers, say for example, Indian Bank, if there are 10,000 customers with the Indian Bank in our branch, but all the customers will be initialized from the same customer class, and only the object values are different, so that we are maintaining the abstraction and generalization. And all the credit process is same, all the debit process is same, all the transaction, what is that, NEFT, IMPS, UPA pay, everything is common to all the operations, are almost similar to all the customers. No privileged, maybe current account transaction may differ, or savings account balance, minimum balance may differ. So that is the, so the abstraction provides us lot of benefits. So abstraction is nothing but taking the collection of data and set of operations that can be performed on the data. So the best example for abstract data type is called class. So any doubt what is abstract data type, definition and explanation? Any doubt with this? What is ADT? What is the example for ADT? And how the ADT is different from normal data or normal data structure? So far we discussed arrays in stack, queue, linked list, trees, and trees and graphs. All are data structure. Only data structure is declared. The operations are not mentioned. But if you take the data structure along with the operations of the data structure, characteristics along with the functions, then it becomes abstract data type. So the definition of abstract data type is a collection of data together with a set of operations on the data. Specifications indicate what the abstract data type operations do, but not how to implement them. They will, the ADT shows the specification will indicate what operations we can perform. Say if it is stack, we'll have the, we'll create a stack, and the length of the stack is fixed. Then the size of the stack is n, and the first position of the stack is 0. And what operations we can perform now, we can push the elements into the stack. Once the stack is full, the stack overflow happens, and if no elements are in the stack underflow will happen. And once if there are some data in the stack, then we can pop the data from the stack. If all the data elements are popped out, then stack underflow will happen. So these are all the various operations we can perform with respect to stack. The same way, data structures are part of the abstract data types implementation. Programmer can use ADT without knowing the implementation. The programmer need not understand the various operations on how it is represented, and just by knowing the logic, they can perform the task. The abstract data type is a data declaration package together with the operations that are meaningful for the data type. The ADT data set, that is abstract data type, available in C is different, C++ is different, and Python is different, Java is different. But the literal meaning, the stack, what is stack and what are all the operations we are performing, that is common. Stack means last in, first out. What operations we can perform is push and pop, stack overflow, stack underflow, and size of the stack. That is, the logic is same in all the programming languages, but few languages will have some ADT, and few say the stack and queue is not a built-in function in C programming, but it is available in the ADT library, STL standard library in C++ as well as Java and Python. In other words, we encapsulate the data and the operations on the data. So we are encapsulating data and operation. You know, encapsulation means capsule which contains the medicine and the outer cover. So the operations are inside, operations and data are inside, but it is hidden from the end user. One side the data will be there, another side the function will be there. Both are dependent on each other, but it is hidden from the external end users through the capsule. Then we hide them from the user. What we can perform with ADT means declaration of data, declaration of operations, encapsulation of data and operations. So we can declare the data and what operations we can perform with the data, and we can encapsulate with each other. The data may be public, private, or protected. The same way operations may be public, private, and protected. Public means accessible within the class and in the main program and in the front functions. If it is protected only by the main program, and private means by the member functions as well as in the main program. If you take the abstract data type, it represents the data and the set of operations on the data. Say data is in an array space. The array is having the size of the array and the length of the array. And what operations we can perform means we can display the array, we can add elements into the array, or we can append uh, elements at the end of the array, or we can add elements in between the array. Then we need to rearrange, insert the array in a particular index position. We can delete an array element based on the index position. We can search for an array element based on the index position, and we can set, and we can find out the minimum and maximum number from the array. We can reverse the array, shift or rotate the array, left shift, right shift, or rotate. All those operations, bitwise operations, are possible with the array. So if you take array as an abstract data type, the various data are related to array is array size and array space and length of the array. The size of the, say your array name is matrix, or if you say the array name is student, the length of the size of the array means our class we have 72 students. So the size, while declaring the array based on the VTOP, the number of students is 72. So that is size of the array. But the length of the array is how many are present. So the remaining spaces are wasted. So how much memory space we are allocating for the array means based on the size. Maybe 100, but only we may be entering or taking only 50 numbers or 60 numbers. The remaining, if it is 100, 100 minus 60, the remaining 40 spaces may be wasted. So these are the declaration part, and these are the functions associated with the data. So both data and operation together is called abstract data type. Any doubt in this concept? The Zoom will end in another 5 minutes. You need to rejoin. Any doubt so far? What is abstract data type? Saurabh, Nishka Singh, any doubt?
No, ma'am.
The abstract data type ADT example, they are taking an integer. Total, how many numbers are there? 0 to 4, 0 to minus 4. It's total 9 numbers. So array is uh, the given array of 9 numbers, integer, abstract data type. The various properties are, it is a number, in integer number, signed integer, negative as well as positive numbers, and what operations we can perform with this particular array means We can add additional numbers. We can add this array with another array. We can subtract the array. We can subtract, say, a common number with all the array elements, or we can multiply the array by 2 or 10 or 100, or this array elements can be multiplied with another array elements. We can perform division. So the data type and the operations which we can perform on the data type is called abstract data type. Here we are taking an integer. The integer is signed integer, positive as well as negative number. And with using by making use of these integers, we can perform addition, subtraction, multiplication, and division. So this is an example for abstract data type. Any doubt? If you take the definition part of abstract data type, abstract data structures help you to organize and store the data very efficiently. We can organize the data, can be organized in the form of arrays, or it can be organized in the form of linked list or stack, any data structure form, and we can store the data in the memory very efficiently that can be accessed. So we'll follow the maximum efficient technique so that we can access it easily. Because say whatever things you are using often, say your mobile, you will always try to keep the mobile in known places, often using places. You will not keep it inside the suitcase, or you will not hide it somewhere, because every half an hour, 1 hour you are accessing mobile. So the most frequently used data, I think you might have studied all those things in operating system. How we are restoring the memory means, how we are keeping storing the data in the physical or logical memory means, most frequently used, rarely used. Most frequently used will be kept very near, and the metadata will be maintained, index will be maintained, and we know where where we can keep safely and where we can access it safely, like that. And most frequently they used data will be kept always in the primary memory, not in the secondary memory. And if you store the data in the register, the processing time will be very less. So we have different types of memory locations now. We have registers, primary memory, secondary storage devices. Within registers we have data register, counter register, all those things, accumulator, the same way. So now the next question comes about how to master data structures, and from where one should uh, easily understand the data structures concept means. If you understand, the very first step towards mastering data structure is to understand the abstract data type. If you understood what are all the abstract data types available in a particular programming language, say if you are using C++ or Python, then you can easily do the programs by making use of the abstract data types. The programming, all built-in functions, macros, and efficient coding techniques will be known. No need to go for recursive function or normal functions or writing the code on your own. The overall, you will get all our built-in functions, or uh, before you build a house, you need to build create a blueprint. Similarly, before you work with the data structure, you need to understand the abstract data types. So through the blueprint, we'll come to know where the pillar is coming, where the main master room and puja room, study room is coming, the measurement and everything, the door and windows, all those things. Some point about abstract data types. ADT is blueprint for the data structure. ADT defines a data structure in terms of its operations and properties. ADT do not dictate implementation. It will not give you the implementation of how to do, what to do. ADT is independent of implementation and programming language. So the abstract data type is the logic behind stacks, queues, all those things. Okay, the class will end in another 1 minute. All of you join once again.